guys, welcome to the next lecture. Today we will talk about modulus in equation. In the previous video, I worked upon the concept of absolute value equations. What about inequations? So let's work on this concept. Absolute value, the definition will always remain the same. So absolute value of x is equal to x when x is greater than or equal to 0, and it is minus x when x is less than 0, right? Now, suppose we want to solve mod x, or absolute value of x is less than a. What's going to happen in that scenario? Again, we will have three scenarios. It really depends upon a. Is a positive number? Is a 0? Is a negative number? So I'm going to start with the first case wherein a is a negative number. We have two concerned graphs here, graph of y equals to mod x and the graph of y equals to a. We are taking a case where a is a negative number. A is a negative number, so it's going to be below the x-axis, right? Somewhere below the x-axis, this is what a is, and entirely y equals to a here, okay? Now, what we are looking for, we're looking for modulus of x is less than a for what kind of x's? Well, a is a negative number. Mod x is always positive. How can a positive number be lesser than a negative number? It's just not possible, which means the inequality, the inequation, mod x less than a is not satisfied by any x. So hence we have a no solution to this problem, because absolute value is always positive, and we are talking about absolute value of some numbers lesser than a negative number. Not possible. Let's check out the next case where a is actually equal to 0. If a is equal to 0, we have two concerned graphs. One graph is of y equals to mod x, and the other graph is the x-axis, where y is always equal to 0, because we're taking the case where a is equal to 0. So y equals to 0 is the other graph that we're looking at. Well, we are about to find out for what x's is it possible that modulus of x is lesser than 0. We are interested in the scenario where modulus of x is strictly less than a, and a is nothing but 0. So that means mod x needs to be lesser than 0. Mod x lesser than 0 happens in no situation whatsoever. Absolute value of x is always positive, so it can never be strictly less than 0. It could be equal to 0 only at one case, but never strictly less than 0. So here we have no solution to the problem that mod x is strictly less than 0. The next case where we will be looking at a as a positive number. So this time we're interested in mod x less than a, but a is a positive entry. There are two concerned graphs, y is equal to mod x and y equals to a, where a is positive. Suppose this is y equals to a, and this is where basically a is on the y-axis here. This is the height. And this is your graph of mod x equals to y, the V-shaped graph. Okay, what are we interested in? We're interested in what are the x's wherein. What I'm getting is that the absolute value of x is lesser than this a. So this height is a. Where is the graph of mod x lesser than this height? Well, clearly it seems like here the height is lesser, here the height is lesser. What x's are these which are generating this graph, this part of the graph? All the x's between minus a and a. So modulus of x is less than a. Clearly, graphically, I can see when x is lying between minus a and a. These are the points where the absolute value will be lesser than a. Okay. So which means that we have three scenarios. Modulus of x is less than a. In case a is negative or equal to 0, we have no solution. In case a is positive, we just have we get an interval, that is where x lies between minus a to a, and then you will have that modulus x is lesser than a. Now let's give values to a and you will figure out what we're talking about. Mod x is less than minus 3. So a is minus 3 here. The two concerned graphs are mod x, which is out here, and the other one is y equals to minus 3, which is a straight line out here. We want to find out for what x is mod x is lesser than minus 3. Well, that's not happening anywhere. Mod x graph is right above. It's above minus 3. This graph y equals to minus 3. So hence, you have a no solution. And that's what we meant by the case 1. Suppose in place of x, you have modulus of 3 minus 2x. And we are interested in the inequality that this is less than or equal to minus 8. What will be our answer in that case? The two concerned graphs are y equal to mod of 3 minus 2x, and the second one is y equal to minus 8. So graphically, let's see here. This is what the graph of y equals to 3 minus 2x will look like. And this is the graph of y equal to minus 8. The thing is that minus 8 is always lesser than this graph. It's much below than this graph, right? So how is it possible that this graph is lesser than minus 8? That is never happening. So we have a no solution. Again, it is the case 1 that I've just discussed, whether it is mod x less than some negative number, or it is some other expression in absolute value less than some negative number. This is not happening for a simple reason. Absolute value is positive no matter what is inside, what term is inside the absolute value bracket. Okay. Finally, let's take an example where your a is a positive number. So let's take absolute value of 3 minus 2x. Strictly less than 6. So the two concerned graphs are modulus of 3 minus 2x and y equals to 6. Modulus of 3 minus 2x will look like this. What? 3 minus 2x equals to y. This is the graph. And this is the graph of y equals to 6. If you algebraically solve these two graphs, you will find out the points of intersection as minus 1.5 and 4.5 respectively. And this point where your vertex lies is 3 by 2. I've done this thing with you guys in the previous video. This time we are interested in what are those x's which will satisfy that the absolute value that comes out of 3 minus 2x is not equal to 6. It is lesser than, strictly lesser than 6. Well, yes, you do have such x's. Clearly, the graph that you see, which lies below the graph of y equals to 6, is this portion of the graph, right? Now, this portion of the graph has been generated by all the x's that are lying between minus 1.5 and 4.5. So hence, this means that this inequality mod 3 minus 2x less than 6. Algebraically, these are the 2 points. And in between these 2 points, if x is between these 2 points, minus 1.5 and 4.5, your fx will be, which is equal to mod of 3 minus 2x, will be strictly lesser than 6. All right. So we have discussed the 3 cases that are: number 1, when A is negative or equal to 0, then what happens with the inequality mod x less than A? What happens to mod x less than A inequality when A is actually a positive number? And I've given you examples related to it. Thank you.